So let's divide between these different cases. All right, so what I want to do is going to go through, as I said, all the possibilities. So let's start off with what we do first. Let's do domains. So domain, first guy, we can see it's all non-negative numbers. Middle one, or sorry, this next one, everything is totally fine. Next one, same story. Next one, well, no, definitely not. We only have positive numbers. We can't even have 0 because I'd be dividing through by 0. So this is avoiding these. This one now, a little bit more delicate. We can have any number, but we can't have 0. So I'll write that in interval notation. And the same thing is true of the last one. So as I said, the behavior of the function, the properties are going to be very closely tied to the exponent you're choosing. Next, range. So what's the range going to look like? Well, again, same story as before. We kind of have to look at the graphs and decide what possible y's appear. So the range, well, this guy, it's actually the same as the domain, if you notice. This guy now has the same range as the first. It's only positive numbers inclusive of 0. This range, the whole thing. So again, you shouldn't think you need to memorize these. You just need to make sure that you understand the process that goes into them. This guy, next, same story. It's the same as the domain. Then the next one, well, this again, it's the same. It's all strictly positive numbers. And then finally, this is interesting. This is, again, all numbers other than 0, isn't it? Those are the possible y's. Okay, what about increasing? When is it increasing? When's it increasing? So we're going to run into some problems here with the looking at the graphs, but when is it increasing? So I'm just going to write down the intervals on which it's increasing. So increasing on, well, it's increasing the entire time. It's an increasing function here. So same story. When's it increasing? 0 onwards, same story again. When's it increasing? It's always increasing the whole time. Nice. This, it's not increasing at any point, never. So nowhere. No intervals. I mean, this is actually a decreasing function, so of course not. Next, I suppose this one, overall it's not an increasing function, but it is increasing on the interval -infinity to 0. And again, there are no intervals on which this is increasing. Nowhere. Decreasing. So decreasing, I'll tell you what I might do. I think I'm going to, rather than have to scroll back and forth, I'm going to keep a copy of this at the bottom, these graphs, so we can always be looking at them. So let's keep them down below. It's a good plan. So a bit further on. So decreasing, what's the deal with decreasing then? Well, it's again not so difficult. It's a little bit more subtle, I think. But we are decreasing on well, first of all, nowhere for this example. Next, decreasing for the negative guys. So from minus infinity to 0, inclusive of 0 if you want. Next, nowhere. Next, okay, so now you're a decreasing function, you're decreasing on the entire domain, 0 to infinity. Next, you're not a decreasing function, but you are if you restrict to 0 to infinity. And now this one is a bit careful. Remember, this is a classic example of something which overall isn't a decreasing function because of the fact that this side is above this side. So it's not overall a decreasing function on the whole domain, but if I restrict to an interval, it might be. So if I restrict to minus infinity to 0 or 0 to infinity, it's decreasing if I restrict the whole function just to those, but not overall. So we think about these two things separately. Okay, so a bit of a subtle point. So next, what about bounded conditions? Well, these follow from the range really, but I'll write them. So we are bounded below by 0. Same thing here for the second case. Unbounded in both directions. Unbounded. Bounded below by 0. Bounded below by 0. Bounded below by 0. Unbounded. So not bounded above or below. Okay. So, any other conditions? Well, perhaps we should do odd or even. Is that a good plan? Are we going to go mad doing odd or even? No, I think it's fine. So I need to move these a little bit further down, sorry. I'm sorry I have to keep doing this, but don't have much option. So first one, is it odd or even? Absolutely not. Neither of them, the domain's not big enough. It's only defined the positive side, so this is neither. Neither odd nor even. The next it's even. The next it's odd. The next neither. The next it's even. So I'm just spotting this purely from the shape of the graph. The next one it's odd. Neat. So maybe a couple more things. So this case, first case, what about zeros? So we've got zeros at positions. Well, only at x is equal to 0. X is equal to 0. X is equal to 0, not terribly exciting, and nowhere for any of those. None of the other ones work. Nowhere. And let's do one more property. Let's think about one-to-oneness. So I know this is a huge dump of information, but it's just good to go through it at some point. So the first one, by the horizontal line test, 1-to-1. And the inverse is quite nice. The inverse is kind of what you'd guess it would be. It's equal to x to the b divided by a. But the inverse is only defined, so you've got to be very, very careful here. The inverse is only defined on the interval 0 to infinity. So for example, in this instance, you could have a half, this first example. So that would be a square root of x. The inverse of a square root of x is not x squared, not overall, because the domains don't match up, or the domains and ranges are wrong. There's too many possible things that we can square. But if I restrict x squared to 0 to infinity, then it works. So the next one is definitely not 1-to-1. Fails the horizontal line test. Next guy is 1-to-1. By the horizontal line test, and the inverse is nice and simple. We don't have any issues here to do with restricting domains. It's x to the b divided by a. It's kind of neat. Next one, same story, we've got to be careful. This is 1-to-1. And the inverse is always kind of what you expect it to be. It's x to the b divided by a. Turns on its head. But again, it's got to be on the interval 0 to infinity. So it makes sense on more potentially. Is that correct? Yes. For the same kind of reasons. If you did x to the minus a half, if you turned everything on its head, it'd be x to the minus 2, which makes sense for all non-zero values. But for the inverse to be a true inverse, it has to only be restricted to 0 to infinity. Again, not 1-to-1 here. Fails the horizontal line test. And lastly, this guy is 1-to-1 by the horizontal line test. And its inverse is exactly what you'd expect. The inverse is x to the b divided by a with no restrictions at all. No restrictions at all on the domain. So beautiful. So this is as comprehensive an overview of power functions as I can give you, really. We've gone through every single possibility, at least if I'm talking about rational or fraction exponents. This kind of covers absolutely every case with all possible situations. So this is, again, I don't think it's something to memorize. It's too much information, but it's something that you should be able to go through carefully yourself and understand each moment, even if writing the whole thing out cold would be difficult. And you should most definitely understand each bit and why each bit is the way it is.